All right, so in this module, we're going to talk about sizing your hardware. I love buying hardware for people. This is probably my favorite part out of my job these days. As somebody with a fake job, as a consultant, people call me in when performance is on fire, things are really bad, they've got to make it go faster. And so often they'll be like, what would it take to make it amazing fast? And we just get to go down the hardware shopping aisle and get to pick out things willy-nilly. So I get to buy probably more SQL Server hardware than anybody else that I know. And I get to run across all kinds of really cool things like rack-mounted wine dispensers. Sure, why not? You just have to be really careful about whether you put this in the warm aisle or the cold aisle. So what we're going to talk about is we've got a set of worksheets that are in our first responder kit. In our first responder kit, there's this Excel spreadsheet that says it's a hardware sizing worksheet, and it's not exactly self-explanatory. I'm going to explain how I use it with clients. Then we're going to talk about just briefly the differences between SQL Server editions, and then whether or not our RPO and our RTO require a SAN. After all these background decisions, then we're going to decide what hardware we want to buy for standard edition, and there's really a one-size-fits-all thing here for standard edition, and then what hardware we want to buy for enterprise edition. Keeping in mind, this session is about hardware. There's nothing wrong with virtualization. I've said a couple of times, I always want to make sure everybody understands, I love virtualization. It should be your default starting point for any new SQL Server. This module is about when you need to buy hardware, and you'll understand what commodity hardware looks like as we go through this. Let's start with our hardware sizing spreadsheet. When I'm buying a server, I want to ask the business what we're buying it for. And the answer isn't SQL Server, it's what specifically is making us shell out hardware money for this. And so the first tab in this spreadsheet, what I do is get everybody together who's got a stake in this brand new SQL Server that we're building. I'm going to get them all together in a conference room, and I'm going to put this Excel up on the projector. I'm going to put columns in here for everybody who's in the room, like my business stakeholders, my IT users, like my manager. I try not to have a voice because I'm not the one buying the server. It's whoever has responsibility over the check writing type stuff. So I say you have 10 votes. You get to pick what you want your 10 votes to be on. I don't care what you're buying, but you only get 10 votes. And you'll notice that there's more than 10 things in this list. I'm going to turn to the first person, say Betty from the business who manages the business unit here, and say, all right, which of these are important to you as we go buy this new SQL Server? You can put your 10 votes spread out evenly across lots of things, or you can put all 10 votes on one particular thing. This exercise comes from something that development shops do. Software development shops will often bring their most important users into a room, and they'll have tables set out with different feature names on them. Replication with different indexes, automatic failover to another data center. And they'll give each customer, say, $1,000 worth of Monopoly money. And the customers go place the Monopoly money on the features that they want the most. This helps everyone understand what I'm going to focus on as a DBA. I'm going to ask each person around the room to tell me what's most important to them, where they want to put their votes, and I'm driving the keyboard, so I'm just typing in, all right, Betty, here's your column. What's most important to you? Well, Betty says, we want faster performance, and then we also are growing larger data across the span of the next couple of years. I may get over to the IT users. Igor from IT may say, look, it's really important that we add in virtualization and that we get easier high availability. So then at the end, I just go down the total column and I'll say, all right, so out of the group, it sounds like the most important things are this, this, and this. And it sounds like these things are not important at all. Well, it's kind of important to us. All right, do you want to change your vote? So the thing is, I only have so much time. I have to focus my efforts on whatever's most important to the business. Sure, maybe using new SQL Server features is interesting to me. Maybe security improvements is important to me. But if it's not important to the business, I'm just going to let them shape whatever we're buying this server for, because this is where our money goes. I talked about that engagement earlier on, where the DBA team put together always-on availability groups, super expensive, enterprise edition, only to find out that the end users just really wanted things to go faster. They would have spent less on enterprise and more on hardware. They would have just tuned the numbers a little differently. So the next question that I'm going to ask, after everybody goes around the table and understands that, the next question I'm going to ask is, are people happy with performance? And because we're DBAs in this room, we usually think that no one's ever happy with performance. But as it turns out, sometimes they are. Sometimes I'm building new SQL servers just because I need to get to a newer version of SQL Server, or because we're growing to new data sizes down the road, or we want high availability and disaster recovery. So I have another spreadsheet for that. It's the same spreadsheet. I'm just changing tabs in the spreadsheet. So I'm going to go to the next tab while everyone's still in the room. And this one's a little different. There's no scores involved in this. But for every application that's on this SQL server, I'm going to copy paste the same 7 questions. I'm going to ask the same 7 questions about each app. Say that this SQL server manages our website and our finance apps. For each of these questions, I'm going to say, what's the answer here? And I'm just going to type it in. I'm not going to run any kind of formula on it. I just want a plain English answer, and I'm going to record who gave the answer, because often later in the project, someone may come back and say, well, who said that? Why would we say the people weren't happy? People love how happy the app is. And then I'm able to give a specific name here. So I'm going to zoom in to just these 7 questions, and I'm not showing the answers over on the side. I'm just doing this for easier screen resolution. So the first question on the app is, are people happy? Are users happy with the current performance levels? And I'm just looking for kind of yes or no. Well, yeah, they're pretty happy with things. Or no, they're actually pretty pissed off about things. All right, question number 2. Have we done a performance check in order to find the easy to fix code and index issues? Now, I need to give a disclaimer here. Of course, I'm a consultant who does that. I do performance checks all the time. But sometimes you're dealing with a third-party app and you can't do anything about that code. Or maybe the developers in-house are all gone. So I'll say, have we done a performance check? Yes or no. And then have we acted on the issues in the performance check? Very often, we'll do an assessment on an app and say, here are the 10 queries we need to change. Here are 15 indexes we need to change. And the developers are like, yeah, but we're real busy right now. We'll get to that later. That's cool. I don't mind fixing the problem with hardware. I just want everyone in the room to understand what I'm up against. If the developers don't want to fix the app, I may be able to fix it with hardware. I just need everybody to be transparent with the fact that we're not fixing the app. Number 4, do we plan to add additional maintenance tasks like doing CheckDB index rebuilds and backups? Very often, when we get to the point where we're about to buy new hardware, all of a sudden we realize we haven't been doing CheckDB. We've only been backing down to nightly backups instead of daily. I want to get those put back into place, but we'll need more horsepower in order to do it. I will typically answer that. The business will ask, well, why? Why would you add more workload? Then we have the discussion about CheckDB and what their RPO and RTO looks like, because they're the ones who drive how much data we're going to lose. Sometimes if they say, oh, you know what, now that we understand it costs money, we'd be okay with losing a day's worth of data, or whatever that number is. Do we plan to add additional features in the app that would store or retrieve data? I don't need a lot of details, but I just have the lead architects in the room, lead developers, and just say, are we going to make this application stuff more data in the database? What kinds of data? Today is the age of big data. Everybody wants to throw everything in the database, and I'm fine with it. It's job security for me. I just want everyone to understand what we're putting in. Do we plan to grow the number of users per application? Often I'll turn to the executives and say, I don't need specifics. But now's your chance to tell me if we're planning on acquiring several other companies, if we're planning on doubling our staff load in the next year. Don't give me any specifics. Just tell me, is there a big growth spurt coming for this application soon? Just yes or no, and roughly what that would look like. Executives will often open up with that with generalities, or they'll say, nope, just expect the exact same number of users. And then finally, are we keeping all data or are we purging history? Say that I've got 3 years worth of history in a SQL server and I'm not allowed to purge data. If this server is going to be up for 3 more years, that means it's going to have at least double the amount of data than when I started. Again, I'm fine with not deleting data. I just need to communicate to everyone that the size of this server is going to need to at least double just to take care of the fact that we're not deleting history. These questions are not to determine an exact size number. It's just to help me start conversations with the business. Because when I start to show you some of the hardware that I'm going to show you on later slides, executives tend to go, "Oh my God, that sounds like some kind of supercomputer. Do you really need some? We're getting by just fine now on a laptop." Well, actually, just a minute ago, you told me it wasn't fine, and you said that we did a performance check and that no one's fixing the issues, and you're about to double the size of the database. If you want to leave users as unhappy, we don't need to buy hardware. We can stay just the way that they are. But if you would like the users to be happy, I'm going to have a different discussion about what kinds of hardware we're going to need. Then we have the last tab that's inside here. How long does this SQL server need to last? And what's the business going to look like at that point? This is another one of those where everyone who's in the room gets to have a voice in the session. They all get to tell me about what they feel for how long the server is going to last and how the user's workload is going to change during that time. Now, when I show this up on the screen and I ask the first question, Bob, how long does this server need to last? What's the expiration date on it? Without fail, the same thing happens every time. Bob goes, "Forever?" Elbows the guy sitting next to him. "I said forever, Frank." "We're going to make it out of granite." And yeah, very funny, very funny. Yes, oh, you're a genius. Robin Williams, for sure. So then I'm going, okay, yeah, that's cool. Now, in reality, how long does it need to last? I truly don't care. I will build a server that will last you 20 years. It's going to have a lot of zeros in the price tag, and the zeros aren't going to be leading. They're going to be trailing. Then I want them to be as specific as they can about how user counts and workload are going to grow. Will it grow by 2x, by 10x, or will it stay the same? Because sometimes this stuff just stays the same over time. Then the last set's a question for the group in here. In order to handle the growth that we're talking about above, are we willing to buy hardware, buy software, add staff, or add consulting along the way? When you do a lot of consulting, or when you move around from company to company, you start to notice patterns in how companies work. Some companies love to buy hardware. They'll throw any kind of money at hardware, but they won't hire any people at all to manage that hardware. So you see one DBA just sweat pouring off of him, and he's got tons of 80 core servers running Enterprise Edition all over the place. And anytime he has a problem, management's like, "You need another server? Can I get you another server? Would you like some flash storage? How about some Brent? Would you like a new desktop?" They love spending capital, just hate hiring people. On the other side, sometimes you see a whole room full of people, just all kinds of people gathered together in a conference room, setting up a war room, working really hard on a project. All right, what can we do to make the SQL server go faster? And then you look at the SQL server and it's got like 4 cores and 16 gigs of RAM, and they're trying to host 2 terabytes of data on it. Different companies have different ways they like to spend money. And if I can just have the customer explain to me, which ones do you guys prefer to buy, then that helps me shape what I'm going to recommend for the SQL server. The more specific the business can be about their metrics, the more specific my server plan can be. But the more general my server metrics are, the more flexible my SQL Server budget needs to be. And I'll give you an example of a contingency plan here. Say that after going through this exercise with a company, we come to agreement. We say that we have about 200 gigs of OLTP data, transactional data today. We expect it to grow. We're growing our website. We just don't know how fast it's going to grow. So for 200 gigs of data, if say that they've decided on SQL Server 2014, I can make that fly pretty quickly with 128 gigs of RAM in the box because most of this is going to be cached. However, if the sales detail table grows in size by 3x, either because we've got all kinds of new sales coming in or because we're refusing to archive and we're keeping longer and longer amounts of history, then we're going to agree as a group that we're going to step up to 2014 Enterprise and chuck this much more memory into the server. The cost of it would be, say, $56,000 for that licensing. We don't need to buy it today, but you need to budget it for next year or 2 years from now if we start hitting that limit. Now, in exchange for that, in exchange for you agreeing to go to Enterprise when we hit that sales table volume number, then I won't care about the developers tuning queries, tuning indexes. They won't have to because I'm going to cover up a whole bunch of sins just with memory. I like using a table size, especially something like a sales detail table or orders detail or inventory table, because that's something that the business understands. I don't like going off of database size because then they just say things like, well, use compression, and that doesn't necessarily make a transactional database faster. Building this slide and coming to this kind of agreement is a lot of work, but this is what's required in order to build a hardware budget for something that you know is going to work well for the next several years. If they were very specific about growth rates and performance tuning, we might come up with a totally different answer. Now, I said that we'd pick Standard Edition. Picking your edition is fairly straightforward these days. We got Standard and we got Enterprise. In here, things get a little bit more complex with 2016. More on that in a second. But my cost per core in terms of licensing is $2,000 a core for Standard Edition, $7,000 a core for Enterprise Edition, which means that if I have a 2-socket box, quad core, this is the smallest physical box that you would buy for SQL Server, that's $16,000 worth of licensing for Standard Edition, $56,000 of licensing for Enterprise Edition. That's a big jump between those two. Now, things get a little bit more hazy when I start to layer in SQL 2016. With 2016 Standard Edition, I get the ability to do things like data compression and partition tables and even all kinds of other developer-oriented features. But I'm still capped at 24 cores max and 128 gigs of RAM max. Don't get me wrong, 24 cores is a huge number. It's very large. I don't think I've ever seen a Standard Edition box go to 24 cores because it's expensive. 24 cores times $2,000 a piece. That's a $50,000 SQL Server box. And when you hit that level, this memory is kind of crippling. Let me put the costs in different terms. Instead of looking at just the licensing, let's include some hardware. For Standard Edition, with an 8-core box, with 192 gigs of RAM, and with solid-state drives for TempDB. Granted, it does not have the cool stuff that the Enterprise Edition gets, things like online index rebuilds, but with 192 gigs of RAM and solid-state drives for TempDB, we're only talking about $9,000 for hardware. So the total combined cost of Standard Edition licensing and the hardware is about $25,000 US. You shouldn't go any lower than this in terms of RAM and a couple of solid-state drives because you're not even close to the same price as the licensing is. Things get a little bit different at Enterprise Edition because when we're talking about 8 cores worth of Enterprise Edition, that is expensive. 8 cores times $7,000 a pop is about $56,000 US. This is too small of a box for that much licensing. Let's say that you go to Tiffany's. You go get your significant other something nice from the jewelry store. Do you bring it home in a Happy Meal box? No, of course not. If you go buy a nice diamond, you bring it home in the nice Tiffany, fancy robin's egg blue box. Similarly, if I'm going to run SQL Server, I don't run it Enterprise Edition on a clown car type box. Check out the pricing of a box with 768 gigs of RAM. It's $20,000. $20,000 is a lot of money. It buys you a nice used car and not even that bad of a new car, but it's still not even close to the price cost of the licensing on this guy. This is why whenever I sketch out what the prices are on my SQL servers, I include the licensing line even if we already bought it, because I need people to keep things in perspective. You don't run Enterprise Edition on a laptop. Remember, things are different under virtualization. In there, we're about packing things into the clown car. But if I'm going to go build a physical box, if I'm going to put $56,000 of licensing into it, it makes sense to go for, say, a $20,000 box. I'm not asking for a $56,000 box, but a $20,000 box is a fair minimum for that much frickin' licensing on Enterprise Edition. The point of this slide is not to get you to spend $20,000 on a box. The point of this slide is don't go to Enterprise Edition if you can get some amazing hardware and run it on Standard Edition. Very often, this hardware running Standard Edition has way bigger bang for the buck than jumping up to Enterprise Edition, spending all this money and not really getting any better hardware to leverage it. All right, so now we've started talking about the differences between Standard and Enterprise. The next thing you need to think about is, do you need shared storage? Do you need a SAN? This is where your design all has to start with this. We have to sketch out how much data the business is willing to lose and how long they're allowed to be down for. And say that they pick this box right here. Say that they say, for high availability, I can't lose data and I can't be down for more than 1 minute. Well, that gets me into this grid of features right here. And this is when I start doing pros and cons between each of the options in that box. Say maybe that we have to use a failover clustered instance like some of the testing or some of the design specs that we did this morning for day 2's homework. If you get backed into a corner on your RPO and RTO, you may have to use shared storage and you may not have a choice. Or maybe you just love your shared storage. Maybe you're one of those lucky folks who has all pure or all solid state storage where it runs blazing fast and it's relatively cheap for you to add additional space. Or maybe you're one of those shops who has just way too much data to fit into local drive bays. If you're not in one of those categories, you should seriously check out just how blazingly fast local solid state is these days. Here's an example of a Dell PowerEdge 730XD. Now you see all those things across the top, and they look like, well, I bet some of you are old enough to remember PCMCIA cards. Those little PCMCIA cards that would stick in the side of an old school laptop, and it had like a US robotics modem or an X jack that would stick an Ethernet out the side. These are 1.8-inch solid state drives, and you can get them up to 1 terabyte in size, meaning I can get 8 terabytes worth of usable RAID 10 space in here, all solid state, and I still have 8 bays down here for those big spinning magnetic rusty frisbees for all my archive data. That's 19 terabytes of SSD space, and I haven't even, 19 terabytes of total space. 8 is super fast and 11 is rather slow. And I haven't even put anything in PCI Express cards yet. Today's modern solid-state space that's available in servers is huge, and you have 2 basic choices out there. Either you can buy the enterprise grade drives sold by the vendors, sold by Dell, Cisco, EMC, Hitachi, whoever. Those are really expensive, but they're supported by the vendor when they break. Or you can buy just Amazon drives. You can get drives from Crucial or Intel or Samsung. And I know what you're probably thinking, Brent, why would I ever put commodity drives inside my SQL server? You just told me not to use a Happy Meal box. Now it sounds like you're having me use Happy Meals. Why would anyone buy $250 drives from Amazon? They can't be that reliable, right? Well, here's the thing. No drives are reliable. All drives will fail. It is just a matter of time. This is what RAID is for. This is what hot spares are for. This is what failing over is for. And if you think, well, the vendor's not going to support my drives. Yeah, these are so cheap. You buy them extra. Buy a handful of extra. Scatter them around the data center. Use them to prop open the door at $200. Who cares? Well, the server vendor's not going to support it. They're going to say, hey, I see those drives in there. Pull them out. If uptime was important to you, you already failed over to another node anyway. Now, most shops, jumping forward instead of back, most shops still end up choosing enterprise-grade drives. A lot of .coms, Stack Overflow is a great example, go into just commodity-grade drives that you can go buy off of Amazon. For example, the first 5 years we were out at Stack Overflow, we didn't lose a single solid-state drive due to failure, and they were all commodity Samsung Intel type drives. When they finally ended up losing a solid-state drive, it was in the build SQL server, not even in a database server. Now, I do have to say, whenever you buy brand new SSDs, like Nick recently bought a whole bunch of Intel PCI Express drives, and a bunch of them failed very quickly upon load. Burn-in tests are very different, but you have the same problem with enterprise-grade drives. Whichever drives you choose, whether you're getting commodity off-the-shelf stuff or whether you're going with enterprise-grade drives, you want to also get the most controllers that you can. Controller count matters a lot here because individual SSDs are so blazing fast these days that they overwhelm a lot of RAID controllers. These can actually end up the bottleneck that holds you back. So having talked about additions, RPO and RTO, your general growth pattern, here's the right hardware for standard edition, all boiled down to one slide. You want 192 gigs of RAM if you're running on 2014 or newer, because yes, SQL Server will use above and beyond the limit. The limit of 128 gigs of RAM applies to the buffer pool, but other objects can go above and beyond that, like caching execution plans, for example. Plus, of course, you remote desktop in, you run apps, your backup app, your antivirus, SSIS, all that good stuff. You're going to get a pair of SSDs local for TempDB. I'm totally fine getting the vendor supplied drives for this because even with the vendor supplied drives, you're talking about $9,600 here. When you look at the personnel labor that's required in order to build this thing out, that's relatively cheap. This is about as cheap as you want to go for standard edition. Now, what about Enterprise Edition? Enterprise Edition is different because it's $7,000 per core US. Whenever I go down the Enterprise Edition route, I just want to remind people, Enterprise is amazing under virtualization because you license the host and then you can run as many guests inside that host as you want. Each of them have their own security, their own patch windows, their own reboot times. Makes a lot of sense with Enterprise Edition to go virtual, but if you need it for performance perspectives, if you're not able to get the performance you need with standard on that bare metal we just described, and you're going to enterprise for hardware, this is a few different options, and they're all maxed out. Take a deep breath when you look at these prices down at the bottom, and then we'll get into details. So I have 4 servers across the top here. I have a 2-socket server with 768 gigs of RAM. I'm going for as few cores as I can get. I'm going for just quad-core processors here. My licensing exposure is about $55,000. if I'm doing 55 grand worth of licensing, it makes a lot of sense to spend 18 grand on the hardware here. This particular server, and HP has one just like it, has, say, more than 24 SSD drive bays in here. So you can pack a lot of performance into this SQL server. In all, $73,000. These are sticker prices. You may do better with volume licensing deals and with volume, Dell or HP Cisco deals. The next step up is 1.5 terabytes of RAM. The same server supports 1.5 terabytes of RAM. This is still cheaper than the licensing, but this is getting kind of expensive. For this same price, you could have bought 2 of the servers over on the left. You could have used them in a multi-instance cluster and use each of their CPUs independently. Granted, if you have a big data warehouse, say a 1 terabyte, 2 terabyte, 5 terabyte data warehouse, then these numbers start to look more attractive than these numbers. 40 grand is not cheap, but it's still cheaper than the licensing cost, and I'm not even including the ongoing costs of software assurance. When you jump up to 4 sockets, so 4 Intel Xeons inside this box, you can stuff 3 terabytes or 6 terabytes of RAM inside these boxes, but these costs start to get pretty terrifying. You don't want to go to the 4-socket route if you can avoid it. The 2-socket boxes, you can get insanely great RAM amounts in here and cover all kinds of sins. But by the time you find yourself being forced to jump up to the 4-socket territory, you want to start thinking about, how am I going to break these databases up into different units so I can get by with a lot more of these cheaper boxes? Because look at that price multiplication there. For the cost of 1 box with 3 terabytes, you could get 4 boxes with 1.5 terabytes each. You could get twice as much memory if you did the divide and conquer approach. Now I'm going to change one thing about this slide. I should also say too, HP has this option down here for 6 terabytes of RAM. You'll notice that the hardware cost is blank because that one on their site is like, call your reseller for more details. That's when you mortgage out the company. Now what I'm doing is I'm going to change one thing about this slide. Right now, my design for these is using the processors with the fewest numbers of cores possible. So I'm using 4 cores here across the board. HP's one is only available with 6 cores on this. So I'm going to change it from between 4 cores to the most cores available. And what you're going to notice is that my licensing cost is going to go up. Right now, it's about 55 grand for the 2-socket boxes, and it's 110 grand up here. Let's go from 4 cores to 18 cores and look at that licensing number. Your hardware costs don't really go up by a lot, but oh, sweet potato, you're talking about $250,000 worth of licensing here when you go through and add much more core counts. This is crazy town. I want as few cores as I can possibly get away with in my workloads, because after all, remember, SQL Server CPUs aren't running at 100%. You're probably running, say, 5, 10, 20% on CPU. Don't buy more CPU power than you need. Take that money and put it back down into the hardware instead. Go with, say, 768 gigs of RAM. 1.5 terabytes of RAM even makes more sense than doing this utter crazy town of $250,000 worth of licensing. So what did we talk about in here in terms of hardware choices? If you need 1.5 terabytes of RAM or less, isn't that a wonderful number? It's huge. If you need 1.5 terabytes of RAM or less, 2-socket servers right now are amazing deals. But once you hit 2 terabytes or more required, you want to start thinking about, how am I going to break this thing up architecturally the next time I buy hardware? Because breaking out SQL servers like one monolithic database into several different individual databases spread across several servers is an architectural project that can take years. Other stuff that we talked about in here, start out with our planning worksheets. These are simple to use Excel spreadsheets that you can gather everyone around a table with and start explaining to them what's most important to you about this SQL server. If they won't give you very accurate plans about exactly how user counts are going to grow or data volume is going to grow, then you're probably going to need to budget your spend over time. Like explain to the business that we're going to start with 128 gigs of RAM today, and we're going to go up to 256 or 512 based on these specific business metrics, records in a table, not anything about database size, which the business just doesn't understand.